The gyroscope is an interesting experiment for the drop tower because its behavior is quite startling. The gyroscope is interesting because as it spins about the axis of the gyroscope with spin angular momentum, the gyroscope performs this motion called precession because at the center of mass of the gyroscope we have weight pulling downward. And from the axis up to the point of application of the center of mass where weight is applied, we have the radius for the creation of torque. Now torque is R cross F, and so when you stick your fingers in the direction of R and turn your fingers on your right hand into the direction of weight, your thumb will point into the screen, which we depict vectorially as an X in a circle, and that is the direction of the vector torque acting on the gyroscope. So as a result, this torque is inward, and since torque equals the time rate of change of angular momentum, the angular momentum for the spin axis must change in the inward direction, which constantly is changing to produce this circular motion around and around that we call precession at a precessional angular velocity. This is the motion that intrigues people about the gyroscope. Now, when weight goes away during drop, torque becomes zero, so the time rate of change of angular momentum is equal to zero, and that means that most people would predict that all the gyroscope would do in the drop tower is stop precessing. But wait, this is in violation of the conservation of angular momentum. Some would argue that the angular momentum from spin is still present, although it is not changing anymore, so it is still conserved. But please note that the angular momentum from spin is not the only angular momentum vector present. The gyroscope is precessing about the vertical axis and therefore has angular momentum associated with precession about the vertical axis. And if we consider the vector sum of these two vectors, we see that the total angular momentum of the gyroscope is not in the direction of the spin axis. This is a fact that is not presented in any textbooks. I found only one that had the true vector diagram you see on the left presented. And when the gyroscope stops precessing, what happens to L sub p? If we say it just disappeared without any torque, we are saying we have just witnessed a violation of the conservation of angular momentum. What does happen is that when the gyroscope is let go in the very beginning, you will see that a gyroscope will wobble a little bit for a short period of time, creating torque at the base to give it precessional motion and precessional angular momentum. So when weight goes away and torque goes away, torque must be added to get rid of this component of the angular momentum, and that means that there is a reaction torque and a reaction force that is acting on the base of the gyroscope in order to stop and eliminate L sub p. And that reaction force acts very quickly to give it an impulse and send the gyroscope upward with a very violent motion, much more violent than the normal force could ever produce. And that violent motion is caused by the elimination of the precessional angular momentum, and so that angular momentum and energy are conserved in the process of the drop. This violent motion was astounding, and it can be explained with the proper vector diagram for angular momentum for a gyroscope.